We now have the GoDirect with a pointed end. The GoDirect first came out with a round end in a 3, 3/7, and 4/7 diameter implant. Here was an article that I had published talking about the new mini GoDirect with the pointed end. And this implant has internal threads, so it can take a variety of other abutments. I'm going to show you a video now that goes through these procedures in great depth. This is showing the 3mm GoDirect and mini GoDirect implants. They do come in different collar lengths. So one has a pointed end, the other has a rounded end. They both have double lead threads for faster insertion. They both have micro threads for reduced crestal bone stress. They have either a 1.5 or 3mm neck on them. The one with the rounded end is straight and then tapered, whereas the one with the pointed end is evenly tapered. The one with the rounded end just comes in 3 lengths and 3 diameters. They both come with an internal set screw that can be removed so that you can add a multi-unit or a ball abutment to it. You could add another GPS extender or a custom cast abutment to it. So it's a one-piece implant that can be converted into a 2-piece. Now Zest came out with an implant that tries to copy this. It doesn't have the micro threads. It sticks up 1 millimeter higher than ours. So it doesn't have an internal thread to give the option of adding other abutments. There are 2 options for placing implants in narrow ridge. Either lay the flap or to do the procedure flapless. So let's look at the standard flap surgery, which is what I recommend for most situations. It gives you the opportunity to flatten the ridge as necessary. This is for the 3mm GoDirect implant, 13 millimeters in length. There's the 13mm line on these drills, and this is a crestal bone drill for very dense bone, and when you turn it in reverse, it'll flatten the top of the ridge as well. So select the 2.3 step drill. Make your initial pilot hole. This is for placing 2 implants. Penetrate to the full depth of the drill with the rounded GoDirect implant. If the bone is soft, you could stop at that point with the 3mm. Insert the paralleling pins. Use them to align the other implants, just as you're paralleling preparations in the mouth. They need to be within 10 degrees of parallelism. If they're canted out, straighten them up with your next drilling procedure. You're going back with a 2.8 drill in dense bone, you could use that to straighten up those sockets. The attachments will work with 10 and 10, which is 20 degrees divergence, but there may be more wear on them, so it's easier to just get them parallel. So here is the GoDirect. Comes on a carrier that is a snap transfer. Just start its insertion, put the tool in and ratchet it to its appropriate depth. You have a 1.5mm collar, which is usually the thickness of the soft tissue. If you need to leave it sticking up a little bit more, you could. Now, flapless surgery, you need to establish whether you have available bone. So you can measure the thickness of the tissue, and then you can map the bone with probes, or better yet, do a CT scan and determine whether you have available bone or not. Much more difficult procedure to do this than laying a flap. Do your tissue punches. Start with a locator pointed drill. In soft bone with the pointed implant, you only penetrate half the depth of the drill. So there's your locator pointed drill. For expediency, cut all three initial pilot holes. Select the 2.3 drill. It steps down to 2. In relatively soft bone with the pointed implant, you can stop halfway down and the implant point will work its way through the bone because of the sharp end. If the bone is dense, then go ahead and finish the site to the full depth. If you attempt to place a pointed implant in dense bone that's only been prepared half the depth, there's a chance of fracture. Put the paralleling pin in and then repeat the procedure to help you line it up. That's how you work your way around the arch. I recommend using 3 of these implants in the edentulous jaw. The middle one will give you what is called indirect retention. And again, try and get them within 10 degrees of alignment. If they're off, then it'd be a good idea to straighten them out with your next drill. In the case of the pointed ones, if you've only penetrated halfway, you could use the same 2.3 drill and just finish the depth of the preparation as you realign the implant. Take the tag off of the implant, put it onto your patient record. This is a 3.0 millimeter mini implant, mini GoDirect implant. There's a snap comfort cap also packaged with that. Just turn it with finger pressure and then ratchet it to place. Now, if the torque seems to be getting too high, and I recommend using torque ratchets above 70 to 80 Newton centimeters, stop and back the implant out and then penetrate to the full depth with the drill. If you determined the density of the bone properly to begin with, you wouldn't need to do this. You would know whether it's dense, and you would have taken care of that at the beginning. If you now find out, though, that it is too dense to get it fully seated, then come back with the 2.8 drill and might as well penetrate to the full depth of the drill, to the 13 millimeter line. There's the 3 of them. The anterior one will provide indirect retention when the denture tries to pick up in the back as the patient's chewing. Snap on the comfort caps Deliver the patient's existing denture with a soft liner. You see there are two neck lengths, 1.5 and 3 millimeters. That's 13. This would be to the 14.5, which is halfway between 13 and 16. And this 1.5 millimeters must stick above the soft tissue for the attachment to snap on. Now you're ready to take your impression. Snap on the transfer that comes with the implant. If you want to cut it off to make it shorter, you can. Snap on your comfort caps. Now you put the abutment analog in the transfers. Pour the working cast. Here's the attachments. They come with a black processing insert and liners with different degrees of retention. This shows the internal attachment, better retention than the Zest, anodized pink, a space in here for this ball to move up and down. This is the internal liner. It's recommended in a lower edentulous jaw with 2 to 3 implants. Here's the external one, which is what we use on bar overdentures now, where we're sure to get these parallel and where we don't need vertical stress braking. It will rotate. So we've got the external and we have the internal. Attachments usually come with the 5-pound retentive one. And you can see how this moves out of the way and allows the ball to move up and down. And rotate. Metal housing and the black insert and the spacer are used for either a chair pickup in a reline, or in this case we're going to manufacture a base plate, stabilized base plate to take the bite registrations. Mount the working cast on an articulator, set the teeth up for a wax try-in. Come back and check the aesthetics and occlusion of that denture base. Process the denture, and then you can remove the black insert and pop in the final one. Check the occlusion. You can also do this chair side using the patient's existing denture. Create space for the attachments. Put some cold cure acrylic on the top, seat the denture. and allow it to cure. You then replace the black insert with the nylon one. There's a special tool for doing that. And that's how we do overdentures. Here's a study done at the University of Manitoba, Canada, where they've been putting 3 of these in the symphysis, have yet to have a single implant failure. And this has become standard procedure, 3 implants in the symphysis to stabilize an overdenture. Here's a case using 4 of the 3mm implants. Laid a flap. This is the suturing, the comfort caps. There's the 4 implants. Here's a case that was done flapless, placing 4 implants. And here is Zest's attempt at copying the GoDirect. They have a cuff that screws on. They sell it as a single unit, but you could take that off, but it doesn't allow you a variety of different kinds of attachments, and they market it as being a lower profile than the ball attachment, but yet it is 1mm higher than our attachments because of this projection, and it doesn't have the capability of adding different abutments.